Okay, we're going to work through Station 2, the vocabulary for this unit. And they ask that you use the word wall to fill in the following definitions. You can use your notes, but we're hoping that you already have learned these terms. An undefined term thought of as a location. So when we're talking about a location and it has no dimension, that should be point. All right. An undefined term thought of as a straight, it's got continuous arrangement of infinitely many points extending forever in both directions. And look, they gave you a line has length, but no width or thickness. It's got length, no width, no thickness. It's one-dimensional. So we know we're talking about a line. It's a flat surface. Whenever you're talking about a flat surface and it extends forever, it has infinite length and width but no thickness, that's a plane. Okay, so now imagine 2 points and all the points between them that are collinear with the 2 points. That's a line segment. A line segment can be measured. Okay. Two angles whose sides form 2 pairs of opposite rays. Okay, let's read that again. 2 angles whose sides form 2 pair of opposite rays. If you have difficulty with that, it's sometimes helpful for you to draw a picture. Okay, so we have vertical angles here. Try to imagine the picture. Okay, here's a ray, and here's its opposite ray, and here's a ray, and here's an opposite ray, and they're the 2 angles who form those. So this are vertical, and these are vertical. When we're asked what are objects that have the same measure, since we know they're objects, objects are congruent. The same measures makes them equal. Measures are equal, shapes are congruent. Now if you look at this diagram, they're asking about point B. Point B in relationship to A and C is between. If we're looking at naming angles or calling what is the vocabulary of angles that have a common side and a common vertex but no common interior points. So you can imagine then we have an angles that have, this would be our common side right here. All right? This would be our common vertex right here. But you notice there's no common interior points. There's no overlap. Those are called adjacent angles. When we have 2 angles whose measures sum to 180, that's supplementary. And my trick for that is if I have an S, this is how my students used to help me to remember, S for supplementary, you can actually turn that S into 180 degrees. Supplementary adds to 180. What is the name of two angles whose measures sum to 90? Complementary. And just as we did the S, if you take the C, that C can easily be converted into 90 degrees. That's how I remember. If we have an angle whose measure is between 0 and 90, that's kind of a small one. It's cute, so we know it's an acute angle. An angle with a measure of exactly 90, it's exactly 90. Many of you call that the right thing, the right angle. An angle with a measurement between 90 and 180. So it could be anything from 90, which is like this, but it's greater than 90. This is our 90-degree angle, so it has to be greater than 90. It looks like this. It's kind of a fat angle, which sounds like obtuse. See, the 90-degree angle looks like a 90-degree angle looks like a corner of a piece of paper, where an obtuse angle wouldn't, a piece of paper, it would peek outside. It's obtuse. An angle that has an exact measure of 180 is a straight angle. And an object that intersects an angle into that intersects an angle into two congruent angles. An object cuts an angle into two congruent angles. So we know it's cutting, so it's bisecting. And it's doing it to an angle, so it's called an angle bisector. Okay, the common endpoint of the ray of an angle. Common endpoint of the rays. So you've got an angle drawn here. There's a ray going this way and a ray going this way. We're talking about what is that thing called in an angle? It's called a vertex. And this one that's kind of sneaked in here on the bottom, it's an object that's formed by two rays with the same endpoint. So if we have two rays that are going in opposite directions, those are opposite rays. Opposite rays look just like a line. Okay, using the figure here, name the following, and we have to use the appropriate notation. We're looking for collinear points, and we know collinear means together on a line, and we need three of them, and the only three that are on the same line are C, E, and D. How about number B, letter B, line segments. Now we can have several answers here. A line segment starts at one point and ends at another. So we're going to say line segment, one of them could be AB. Be very careful how you note that. You see the notation with the line, the little segment up above it? That says segment AB. Let's find another one. How about this piece of this line here? Segment CE. Remember, a segment is just a part of a line. So how about this here? Segment ED. How about this long piece here from C to D? We could also have CD. And you can name them any way you like. I could have named that AB, could have been BA, it could have been EC, and it could have been DE or DC. Whenever you have 2 points, you can name a line segment. So you could have also named BD or BE, but we tend to use the names of the segments that are pictured on the plane. 4 coplanar points. Coplanar, that means together, on a plane. 4 coplanar points can be any of these 4 points that we see. How about A, B, C, E? Any of those. You can even add D if you want it, but that's actually 5. 2 opposite rays. Now be very careful. We're looking for a pair of opposite rays. Opposite rays have the same endpoint. So I'm going to look over here, and I see this endpoint E. So one of my rays is going to be E passing through D. E passing through D. Or you could say E in the direction of C. E in the direction of C. But see how each of them has the same endpoint. That's what makes them opposite rays. And how will we name a line? You can name this line, you only need to have 2 points. So just like we had several names for segments, a line is identified by 2 points. We have several lines here. CE that we could name, CE, but we have to be careful with the notation. You want CE to have a line over it with the arrows. ED you could call it as well. Now let's look here. Plane. How many points do we need to name a plane? The plane, we need 3 points. C, B, E could be a plane. Or we could call it plane D, E, B. So you notice with a plane you have 3 points. With a line you have 2 points. With a segment you have 2 points, but they have length and they stop. Okay? So that's our Station 2 vocabulary.